Inequalities. You're used to seeing inequalities that look a lot like this here. And you're used to graphing them where you're used to saying it's an open circle if you're not including the point, and a filled in circle if you are including the point. Well, we're going to use a slightly different notation. Whenever we're not including the point, we're going to use a parenthesis. Wherever you are including the point, you want to use a square bracket. It's referred to as interval notation. And so we would write it like this. We would include 5 all the way up to 8, but not including 8. So your interval notation that we have over here is exactly what it's represented as in a number line. You have your square, followed by your 8 with a curve. So, as you're looking at your interval notation, you always put the smallest number first, followed by the largest number. If you have equal to's, then you use square brackets. If you only have less thans or greater thans, then you use curve parentheses. Now, down here we have x is less than or equal to 2. So that means you need to go to 2. It's equal to, so it's square, and you're less than, so you're going to shade to the left. So you're really coming from negative infinity. The infinities, whether positive or negative, are never included because you can only include numbers, and infinity is a concept, not a number. So it's a curved here. The smallest of these two you put first, which is the negative infinity, followed by the 2, and you're including the 2, so that's a square. So we're going to solve more inequalities here. Now, in solving inequalities, you want to go ahead and treat them just like you were when you were solving an equation. You want to try to get the x's on the same side. So now we're going to go ahead and divide by, or subtract the negative 5x, so we get a negative 4x greater than 11. Then we're going to go ahead and divide by negative 4. When you divide by negative 4, you need to switch your inequality sign. Let's take a look at the bottom down here. Negative 2, you guys would agree, is less than 5. If you multiply both sides by a negative, like we were doing over here, you get then a positive 6, and you get a negative 15. So what was the small side now becomes the big side. What was the big side now becomes the small side. But you notice if you're just multiplying both sides by a positive, the inequality sign holds true. So that's why we switched our inequality sign. And so then we end up with x is less than or equal to a negative 11 over 4. If you wanted to write the interval notation, it would be given to you like this. Because you're starting here going down towards negative infinity, but you're not including this one, so it's curved. You never include the infinities. Here you have a compound inequality, but you're still going to solve it just like you would normally. You need to try to get x by itself, so you got to get rid of the plus 3. So you're going to subtract 3 from, this case, all 3 parts. So then you would get this. Now you want to get rid of your 1/4. So now you got to multiply all 3 parts by 4. Notice over here you get a negative 20. In the middle, your 4 and your 1/4 undo each other. Over here you get an 8. If you wanted to do interval notation, you'd have to put down your negative 20 and your 8, smallest to largest. Your 8's being included, so it's a square. There's no equal to here, so it's a curve. Now we'll go ahead and solve this one here. To solve this one here, you want to eliminate the parentheses, so distribute there on the left-hand side. Here you're going to have to FOIL on the right-hand side. Now it's just quadratic. You'll notice that your 12x squared will drop out on each side when you subtract the 12x squared from both sides. Now you're going to have to add a 5x to both sides. Now you got to get rid of your 15 by dividing by 15. You're only dividing by a positive number, so you don't switch your inequality sign. And here's your interval notation if you wanted. Here we have absolute value less than a negative 2. Well, once again, absolute value, whatever you get out of it's positive. So can a positive on this side ever be smaller than a negative on this side? And the answer is no, so it's no solution. Taking a look at the one right below it, though, if you have absolute value greater than a negative, well, can absolute value ever be greater than a negative? Yes. Isn't what you get out of an absolute value always positive? And isn't anything always that's positive always greater than a negative? So yes, it would be all real numbers, with the one exception of what causes you to divide by 0, because you know you can never divide by 0. So in this case, it would be all real numbers, except you cannot have x being negative 8, because that's what causes the bottom to be 0. So we want to go ahead and solve this one here. Well, when you look at this, we have a fraction being less than 0. When is a fraction less than 0? When it's negative. What's the only way a fraction can be negative is if the top's negative and the bottom's positive, or vice versa. But you notice the top's always positive, so the only way this fraction can be negative is if the bottom is negative. So that's all we're going to say, is that the bottom has to be negative. Now notice there is no equal to here, because if I had an equal to, I'd be dividing by 0, and I don't want to divide by 0. So we'll just go ahead and we'll solve that like we normally would. And then there's your interval notation. So what does absolute value of a number, or absolute value of x less than 4 mean? Means all the numbers within 4 units of 0 on your number line, because absolute value is distance from 0 on your number line. So you can go 4 units to the right, 4 units to the left, and anything in between, because it's less than 4. You could write that as an inequality here. Negative 4 less than x is less than 4. You could write that as two separate inequalities, less than a positive 4 but greater than a negative 4, and joined with an and statement. What does absolute value of x being greater than 4 mean? Means all the numbers more than 4 units from 0 on the number line. Because once again, absolute value is distance away from your number line, or distance away from 0 on your number line. So it's everything more than 4 units away, because 0 is right here in the center, so you got to be more than 4, so that would be up here or down here. Well, you could write that as either x is less than a negative 4, that would be this region, or x is greater than a positive 4, that would be this region. There may be times you'll want to write it as x is less than a negative 4. You might want to write as a negative x. Okay, I had a typo over here, which I fixed. Now, the right-hand side's still the same. You could have the negative on the other side, which makes it negative x is greater than 4. Well, we can summarize those and say, well, absolute value followed by less than, you could write as one compound inequality like this. So here we have absolute value followed by less than. So you can write it as one compound inequality. Basically, you ask yourself, okay, if what's inside is positive, it does nothing, so you just drop the absolute value. And that's what we have here. Then it's another less than. And then what you put over here on the left is always the opposite of what's on the right. So it's got to be the opposite of this, so we get a negative 1. Well, as you look over here, absolute value followed by greater than is two separate inequalities. So you basically say, okay, if what's inside is positive, absolute value does nothing, so we get this. Or if what's inside is negative, your absolute value makes it positive by multiplying it by negative 1, still greater than a 5. And then you just solve each one of these like you would normally. And so you solve each one of these. And so then you want to go ahead and graph those. So at 4, you're going to have a square and shade to the right. Here you're equal to, so you're going to have a square at 2/3 and shade to the left. Interval notation would be this here. Whenever you are joining two separate intervals, you use a U for union. So it's coming from negative infinity up to 2/3. Here you're starting at 4, going to positive infinity. Here you'd want to go ahead and multiply everything by 3 to get rid of the dividing by 3. So we get this. Now you want to get rid of the plus 5, so subtract 5. Now you want to get rid of the 2, so divide by 2. Now that as an interval is this here.